Concrete is strong. We love it because of its most unique property that it gets stronger and harder with time. But it's not nearly as strong as it's needed to make roads and buildings out of it. So then how do we make roads and buildings out of concrete? If you take a slab of just concrete and support it at its ends, then when you put a force on the top, if you put a lot of force from the top, then this force will cause the concrete to deform, and as a result, the concrete will end up bending. And we have studied before that whenever materials deform, they try to snap back by generating restoring forces. And these restoring forces, which we calculate as stress over here, they depend upon the amount of deformation. Now, if you look at this bent concrete carefully, then you see that the top part has become shorter because it's the inside of the curve, and the bottom part has become longer. As a result, the top part, which has become shorter, is under compression. So this is under compression. So there's a lot of compressive stress generated on the top. So there's compression on the top. And at the bottom, because it's the outer side, which is longer side, there's a lot of tension. It has been stretched. So there's a lot of tension. So there's tension on the outside. And we can visualize this by using an example. Imagine we had a beam like this with some sticks through that. And if we bent this beam, just like the concrete, then notice the sticks at the top come close to each other. Just similar to this, the molecules on the top of the concrete come close to each other, and that's why the sticks over here, we could say they are compressed. And similarly, notice the sticks at the bottom, they have gone far away from each other. Similarly, the molecules at the bottom go far away, and that's why they're under tension. Now, concrete turns out to be quite brittle. It doesn't mean that it's weak. It just means that if you put a lot of stress and you go beyond the elastic regions, then very quickly it will break. And another property of concrete is that it has a great compressive strength compared to tensile strength. In fact, it turns out that the compressive strength of concrete, is roughly 10 times its tensile strength. Which means we don't have to worry too much about concrete getting compression. It can withstand compressive forces very nicely, but it is very poor at withstanding tensile forces. And as a result, if this weight is too much, then the concrete will end up cracking at the bottom. And that is very bad because, first of all, we can't see that. And if the bottom part of the concrete cracks, then the whole road can break. And this is very bad. So how do we make our concrete stronger? Well, we do that by reinforcing this bottom part of the concrete with steel wires. So we use steel reinforcement. This is steel. Now, the good thing about steel is, like, unlike most materials, which are good in compression, but they are very bad in tension, steel is unique in that it is having pretty much same compressive and tensile strength, and the compressive and tensile strength of steel is way more than that of concrete. So reinforcing concrete with steel will actually make our entire concrete stronger. And so what we do is we lay down our steel wires, and then we pour concrete on top of that. So we pour concrete on top of this steel. We make sure the steel wires are pretty much at the bottom where we need the reinforcement, and we allow this concrete to get set along with the steel in such a way that the concrete forms a bond with the steel. And now if we put that same load as before, we put the same weight as before, again this concrete is going to sag a little bit, not as much as before because now we have steel reinforced it, but anyways, it's going to sag. However, this time the tensile forces acting at the bottom of the concrete is shared between concrete and steel. And since steel is way stronger than concrete, most of the tensile forces are taken up by the steel. This is very similar to how the bones in our body works. Whenever you carry any weight, most of that weight is actually taken up by the bone. Only a small portion of that weight is taken up by the flesh or the muscles that are attached to the bone. The concrete is pretty much like the flesh, and this steel now literally acts like the backbone of this whole system. But of course, if you put too much weight on this, as you start putting more and more weight on this, the tensile forces start increasing more and more. And even though steel is taking the majority of that force, the concrete is taking a small portion of that force. And as those force increases, eventually the concrete will start developing cracks again. Again, this is very similar to what happens in our body. If you were to carry too much weight, which your bones can withstand, by the way, but because the forces are being shared between the bones and the flesh, there can be muscle fracture. There can be tears. Your muscles might get pulled. And so something similar is going to happen over here. The steel is quite strong, but since the forces are being shared, if you put too much weight, eventually this thing will crack. And again, this could be bad. So this reinforced concrete is good, it's strong, but the big question is, can we make it stronger? I mean, yeah, of course, we can put a lot more steel wires over there, but there's a limit to how much you can put over that, right? Besides that, can we do something else to make it even stronger? Turns out that we can. One way in which we make the concrete even stronger today is by changing this procedure of reinforcement just a little bit. So we take these steel wires and we're going to pour concrete on top of that. But before we do that, we stretch these steel wires by pulling them with huge forces. So we are going to stretch these steel wires. So let's say, yeah, we're going to stretch them. So we're going to stretch them with huge, horrendous forces because steel is extremely strong. And because of these forces, our steel is going to end up stretching. Oops. It's going to end up stretching like this. So our steel wires now will be under tension. And this is where it gets really interesting. Keeping these tensile forces, we are going to now pour concrete on top of this. All right? So we're going to pour concrete on top of this, keeping the steel wires stretched. And then we're going to, once the concrete has set and it has bonded with the steel, then we are going to remove these tensile forces. Question is, what's going to happen? Well, notice because the steel is under tension right now, the steel tries to snap back, so there will be restoring forces acting on the steel. So steel tries to snap back by putting the restoring forces, but the steel can't snap back because there's so much concrete over there. And since the concrete is bonded to the steel, now these restoring forces are transferred to concrete. And as a result, the concrete ends up being compressed. You get that? Because the steel is trying to snap back over here and is bonded to concrete, the concrete ends up undergoing compression at the bottom. It'll undergo compression. And you might be wondering, like, whoa, why are we doing that? Well, as this bottom layer undergoes compression, the bottom layer comes closer to each other, so the bottom layer becomes smaller in size compared to the top layer. But remember, your concrete slab can't maintain shape like this, so as a result of the compression at the bottom, the concrete ends up buckling, somewhat like this. And so this concrete, even without any load or even without any weight, the concrete is already buckled, it's already stressed out. So the bottom layer now is under compression, and of course the top layer is under a little bit of tension. But we're going to make sure that the tensile force is not too much, so not too great, so the concrete won't crack. This kind of concrete, which already has a stress even before putting the load, we give it a name. We call that as pre-stressed concrete. And the name itself tells you pre because even without loading, it's already stressed out. Can you see where we are going with this? Can you see how this is beneficial to us? Well, now when you start loading this, if you now start putting weights on top of this, so if you put weights on top of this, because of the downward force, the concrete now will snap back to its original shape. In simple terms, what we have done is, since we know that putting weights is going to bend concrete this way, to counter that, we made sure initially itself the concrete was bent the other way, so that when you put load, the bending cancels out and the concrete ends up relaxing. So even under this influence of the weight, the concrete now is in its relaxed, in its natural state. And as a result, it can now withstand even higher weights. And this pre-stressed super strong concrete is used today in building, in constructing dams and constructing roads and building new buildings and everything. And so notice that understanding the elastic behavior of concrete and steel allowed us to enhance the properties of concrete and make it super, super strong.